Hi, it's time for another math. Easy. So we're going to discuss properties of the definite integral. I introduced definite integral in the video, in a couple of videos before, and you can see those in the video link below. Basically, I'm going to do some properties of it, part one of the series, because depending on how long this video series is, basically, this one here, this definite integral is defined as this sigma or this s sign, this integral of from a to b of f of x dx. All it means is it's defined as equaling the limit as n approaches infinity of sigma notation I is 1 up to n f of x I times delta x, and this is just the area of a rectangle, and this is summing up infinite rectangles, and where delta x is just breaking up the rectangles into equal widths. So if you have n of them, you're just going to have b minus a divided by n here. Yeah, and you can see in the introduction to definite integral in the video link below in the info. So basically from this one, this is defined for when b is greater than a in this case. Yeah, and that brings me to property 1 here. So if you didn't have this case, if you just switch these up around, so you had b and a here of fx dx, then by the delta x, the only thing that changes is going to be the delta x in the definition. So delta x is going to equal to this is going to be, what is it, a minus b over n, because that's going to be from this minus that. And this just equals to, I'll just put the negative out, so negative b minus a. Just take the negative out over n here. So that's all it's going to change, is you're going to have a negative here. So you can put a negative, and this is a b fx dx. So yeah, from this one, we could just change this for, instead of the integral from a to b, from b to a and etc. All we do is just change just add a negative there. So that's property 1. So now this brings me to property b. Let's say if a equals b, and so if you had a equals b, then the delta x in the definition is going to be, well, a minus a or b minus b divided by n. This just equals to 0. So from this we get the integral of a to a of f of x dx is equal to 0 here. This just means you have no rectangles. So the width of the rectangle you're breaking up is 0. Okay, so now let's get to property 3. This one is basically if you had f of x is a constant, or just c equals to c, so we'll just write f of x equals to c, and it's a constant number, then the integral is going to be this, c times b minus a. And and the proof for this is pretty basic here, because remember the integral is just the area under the curve. So if you had a constant, so let's just graph f of x here. So this is f of x. Yeah, so here f of x is equal to c. It's just a constant. Whenever if it's constant, just a horizontal line here, because at whatever x value, you're just gonna have the same value here. And then from b to a, let's say this is b and this is a here. Remember, it's just gonna be the area under the curve, and it's just gonna be a rectangle here. And this height is c, and this is b minus a here. So the area is equal to c times b minus a. So and that's the answer. So now property 4 here, let's get to this one. This one just states that if you have the integral of two functions added together here, d times dx here, it's just going to break, it just equals to two separate integrals. This is the integral of a to b of f of x, and this is the g of x here. And the proof for this one, you could do it visually and basically break it down into the definition. Yeah, so we write it down in the definition as a sum of, as a limit of sums here, so it will look something like this here. And now with limits, we could break it down into just a limit of two separate functions here. So we could just write this down as limit. Yeah, actually, before the limit, just break them to two different limits. So you could actually break it up into two different sigma notations or sums here. See a video link on intro to sigma notation to see a basic proof for this. But it's pretty straightforward. And then from this one, we could write it as two limits. Yeah, so we just write it down like this one here, and remember by definition of integral, this one is this is just the integral of f of x dx, and this is the integral of g of x dx. So this equals to limit a to b, because that's what delta x equals to, f of x I dx. Oh no, not the x. Actually, get rid of the xi. So that's there, plus now this one is just going to be integral a to b of g of x dx. So there's our proof here. So that's the proof for this one here, and you could also do it visually here. Visually here, from just graphing this one out from a to b, this is f of x, call that f of x. And now let's say g of x, if we just graph it by itself, looks something like, let's say something like this. So this is what g of x looks like. Actually, I'll just change up g of x. Let's make g of x look something like this, just so it doesn't have to touch there. So anyways, if this is g of x here, Then remember, the area under the curve is all that the integral means. So then if you have this area, now you have this area here, and now this is just the addition of the both areas. So you're going to have something like, if that looks like that, we're going to just draw exactly f of x. So yeah, draw this one out. This is f of x plus g of x. This is a delta x here. So now this one and this point here is just going to be f of x here. This is just g of x, and this is f of x. And so we're just adding these two here, and this total one here. Actually, I made a mistake. No, that's f of x, and then this one, yeah, g of x up to 0, so this is g of x here. And I just add it together here. So that's yeah, that's just visually, you could see it like that. Yeah, actually, I'm gonna just modify property 4 to include the negative. So if this was plus or minus negative, this can be plus or minus that one here, and this comes from the same exact proof. Just put a negative here, so if we had either or, then this is gonna be a negative instead of a plus. This is gonna be a negative instead of a plus. This is going to be a negative instead of a plus. So that's, the proof is exactly there. And then instead of adding this one, we're just going to subtract it from this. So you'll have some value in between here. Yeah, so in between g of x and f of x there. Yeah, or less than f of x, depending how big it is, because you're subtracting from g of x. So it could be somewhere here. Alright, so now the last property I'm going to get through is just this one here. If you had a constant in front, so this integral of c times f of x, this just equals to c times fx dx. All you do is take the constant out. Number c is a constant here. And the proof for this is pretty basic here. And the proof, you can just write it as this limit here, again, the sums, and then just showed in my earlier video. For this one, with sums, you could just take any constant out, and also with limits here. So this just equals to c times whatever this one here. Yeah, so just write it as that, and this just equals to CAB. You can see remember, you can also see in the video link and info below on signal notation. I had some properties I defined in the intro to it. And also this is just going to be fx dx. So this just equals it by definition. So that's all this is. A simple proof for it. Okay, so now just do a quick example using the properties here, and right now I'm not going to use antiderivatives yet because I haven't showed that yet, but I'll do that in my later videos. It's a much easier method. But now we're just going to break this down exactly like the properties, and that's with property 4 here. We can just break it down. Yes, let's get back to this. So this one would just equal to, well, sigma 1, 0. We could break this because it's a plus. So 4 dx plus the integral 0 to 1 of 3, we could take the constant out, so 3x squared dx here. And now this one here, we could use that property 3 here, because this one's a constant, so this is just going to be 4 times 1 minus 0, so it's 1. And then plus 3 times, now this integral, I showed this in the intro to the area problem in the video link below. You can see that for this one here, and this one actually equals to 1 over 3, which I showed. So this one's going to be 1 over 3, and the answer is going to be, well, this one 4 times 4 plus 1 is just going to be 5 here. So that's the answer here. So yeah, I just wanted to just quickly show that you could just break stuff down here. And this one is from the intro to the area problem video. You can see that in the video link below. And this one, well, I'll show how I get this one here using a bunch of sigma notation rules and summations of infinite rectangles. Well, that's all for today. Hopefully you learned about this. Remember, you can always download these notes in the Dropbox link below, and just let me know if it doesn't work. But that's all for hopefully you enjoyed and learn a bit. And remember to stay tuned for another math easy solution.